All right, let's look at this free response question on a function defined by an integral. We have the graph of f shown to the left. It consists of two line segments and a quarter circle. And it says here, let g be the function given by the integral from 0 to x of f of t dt. And whenever we see a function defined by an integral, especially in an FRQ, this is what I want you to do. We're going to annotate what that means for us. G is going to be equal to the area of the graph that we're looking at. G prime would be the derivative of the integral, which would cancel out, and so we're just left with f. And then finally, G double prime would be f prime, or the slope of f, the slope of the graph that we're looking at. So let's look at this first question. Question A, we're asked to find g of 0, g of negative 2, and g of 6. So g of 0 is going to be equal to the integral from 0 to 0 of f of t dt. And since we're starting at 0 and ending at 0, we have no area, and so that answer would be 0. G of negative 2 is equal to the integral from 0 to negative 2. And notice that our lower limit there is higher than our upper limit, which means we're going in the backwards direction. And so whatever area I get, remember that G equals the area, but whatever area I get, it's going to be negative because I'm going backwards. Now if we look at the graph from 0 to negative 2, that's this triangle right here. And the area of that triangle is 1/2 base times height, 1/2 2 times 2, but that area is below the x-axis, and so it would be negative 2. So I was going backwards because it was negative. The area is below the x-axis, which is negative, and of course two negatives make it positive 2. And finally, g of 6 equal to the integral from 0 to 6 of f of t dt. And so let's go back to the graph. The triangle from 0 to 2 matches the one we just found. That area is 2. I have a quarter circle. So let's think about the area of the whole circle, which would be pi r squared. My r is 2. So the whole circle would be 4 pi. And so, of course, a quarter of that circle, if we divide by 4, would just be pi. So this area is pi. And then this final triangle, 1/2 base times height, base is 2, the height is 4, and 2 times 4 is 8, divided by 2 would be 4. So from 0 to 6, I have the area 6 plus pi. All right, let's move on to the next part. Question B. Now give me just a minute, I'm on the new slide. So I need to write again. G equals area. G prime is equal to F, which is what we're looking at. G double prime equals slope. So my question here says find all values of x on the open interval -2, 6 at which G has a relative minimum. There's a flashcard phrase. G has a relative minimum, and so I want us to annotate what that means. If G has a relative minimum, that means G prime goes -0, positive. G prime changes from negative to 0 to positive. And if I go back to my annotations, I know that G prime is equal to F. So I'm actually looking for when does F change from negative to 0 to positive. And obviously that happens right here at 0, 0. So then to answer our question, G, let me try that again, has a relative, and I could have abbreviated that, relative min at x equals 0, because this is where we have to be really careful. Remember that whenever you write the word because, I always want you to follow that up with whatever's given. In this case, f is what's given. However, my annotation that I wrote up on the question is about g prime, and that needs to be the reason for my answer. So I'm going to say f, which is g prime, changes from negative to positive at that point. All right, let's move on to the next question. Question C, find the absolute minimum of g on the interval -2, 6. Now, when we see absolute minimum, again, it's a flashcard, and what we should be thinking, of course, is candidate's test. Absolute minimum means a candidate's test. So my candidates are going to be any critical numbers and, of course, the endpoints. And notice that it's the absolute minimum of g, so I need to be finding the value of g at these points. And again, let me take just a quick moment to annotate over here on the side since I'm on a new graph. G is area, g prime is f, g double prime is slope of what we're looking at. So my candidates are going to be -2 and 6 because those are my endpoints. But I also need to include my zeros. My zeros here are 0, and then we also have a 0 at 4. But notice at 4 there's no sign change. And so while 4 would be a critical number, since the graph is positive on both sides of 4, we don't have a relative min or max. And so we could just put no sign change there, and we don't actually have to find the value because we know that it's not going to be a minimum or a maximum because the sign didn't change. So let's fill in these values. G of -2, and notice we've already found this value back in part A. If you look back at part A, we found that G of -2 was equal to 2. G of 0 was 0. And G of 6, I hope I'm remembering correctly, I believe was 6 plus pi. And so we're looking for the absolute minimum, and the lowest value there is 0. That would be our minimum. Now, before you answer this question, we need to go back and look and see what the question asked. It asked us to find the minimum value. Of course, in this case, they're both 0, so it wouldn't, in this example, it doesn't matter. But usually you need to think about what question are they asking and make sure you answer that question. So G's absolute minimum value is 0. And it says justify your answer, but remember with candidates test, if we do the table and show the work like we did here, we've already justified our answer. And so we can move on. All right, question D asks us to write an equation for the line tangent to the graph of G. Now be very careful about this. I know that we've memorized the formula in terms of f, but we need to be able to change that to whatever function they're asking us to find a tangent line for. So in this case, my formula is going to be y equals g of a plus g prime of a times x. Let me pause for just a moment. All right, sorry for that interruption. So we have our tangent line formula there, and remember that G is equal to area, G prime equals F, G double prime is the slope of F, and so our A value is -2, so really Y is going to be G of -2 plus G prime of -2 times X minus -2. G of -2 we've already determined is equal to 2. We found that in part A. G prime of -2, if I go back over here to my annotation, G prime is equal to F. And so really g prime of negative 2 just means what is f of negative 2. And if I look at my graph, right here, the graph of f at negative 2 is equal to negative 2. So I'm going to put negative 2 times x plus 2. And you could do simplification. I really want you to stop right there, because if we try to do simplifying and you make a mistake along the way, then you're going to lose the point for this correct tangent line equation. So once you've substituted in the values, let's just stop and move on to the next question. Our last part here says find the intervals on negative 2, 6 where g is concave down. So I have g is concave down. That's a flashcard. We need to annotate. It means two things. It means g double prime is less than 0. It also means that g prime is decreasing. And this is why I want you to know both of those things, because in this problem, we don't have g double prime, we have g prime. Because remember, let me annotate one more time. G is area, g prime is equal to f, g double prime is the slope of f. And while we could look at the slope of f, why not just look at f? G prime is equal to f, and so g prime is decreasing really means we're looking for when f is decreasing. So if we look at our graph, you can see that f is decreasing right here. It's on the interval 2 to 4. And so our answer would be g is concave down on the interval 2 to 4, because we have to justify our answer. Again, every time you write the word because, the very next thing that should come after it is what's given. In this case, that's f. Because f, but remember my annotation was about g prime. So I need to say which is g prime is decreasing on that interval. There we go. And that brings us to the end of this problem.